So today's topic, they are in an extension version of the fundamental mathematical B in the part B. So I would like to start with the introduction, applied general equilibrium analysis, and then people use another term, the computational geometric general equilibrium is a CGE model, for example. First of all, we need to think about the real function of the mathematical models. Real world, too much complex to understand. People sometimes focusing on some specific point or another point. Then people speculate what is happening or what happened in the future. In the sense of the mathematics, we try to represent the real world to extract the necessary component, get accurate future prediction or interference. In the people can share such kind of representation to share benefit and risk. So this is a society. Therefore, the part of that work for the people studying the mathematical sciences try to represent the real world, hopefully in accurate way, or the statistically validated. In other words, for the so quantitatively and qualitatively. There are other type of the function, but normally we are thinking about prediction and the interferences for real world, or to get benefit or the predict understand the risk for to avoid such kind of situation. What kind of the factor is necessary is very important. Then the people need to think about some causal relationship. Normally it's in time. Then past, present, future is the very understandable segmentation. But in a sense, depending on the time scale, what you want to know tomorrow, the event in tomorrow or the next year or 10 years after, the time resolution depends on the case or requirements. Mathematical model need to be designed for the precisely in the maximum way, and then to represent or simulate such a causal relationship in a possible way. And we say it is a cause and effect or input and output. Then how much input it can be obtained and what kind of the effect can be computed. This is the real issue for the mathematical science. Today's topic for the thinking about structure of the economy. Then we need to set some assumption in the sense of the representation, because we cannot draw everything in the real world. That's why we try to extract some of the principal component or necessary component to compute here, and then set some strong assumption. In the real world, once people interfere, situation changes. That's why this is worth one of the most difficult model to represent in the world, because once people understand the model, people use this model, they use the actual world to get the benefit. Therefore, situation changes because of that they try to interfere again and very recursively. That's why the study of the economics is tough. Too much focusing in the precise point is a bit difficult. That's why some of the economists were the computational economists thinking about some microscopic or macroscopic view of the situation. Then, okay, the people, what kind of the behavior people take. This is one of the strong assumption. Then they say demand and supply of goods and services should be based on their respective motifs. This assumption can be transferred to the mathematical the formulation. Then we need to think about the component. Of course, such a resolution component also varies depending the case or the assumption. But the full actual function model, what kind of the input can collect, or that can be collected what kind of effect you can try to think, or the target of interest. So then at least we need to think about 3 components here according to the computational economy. So this is the market. This is the household budget, enterprises budget. Okay, it totally depends on the word. I mean, some country or the political business, government strongly interfere the market. That's why market balance or the structure bit unclear. That's why this is the kind of ideal market, we say. Price is determined so that demand equals to the supply. This should be balanced. This is a kind of the strong assumption in the market. The proper government interference should be kept this kind of balance somewhere according to tax or the design, the law, or something else. Otherwise, people try to change the balance because of their own benefit. That's why keeping a balance is very important. It's quite similar for the ecological system in the world. Okay, now we have the global heat or the boiling now. So then the people are so hectic for the high temperature, hot weather. So then this is the kind of the disease of the earth, of the original circulation have some the problem. So anyway, back to the discussion of the economy. So then if we assume the market, household budget, enterprises, so then this is a strong assumption. For keeping the balance is determined so that demand supply. So then household budget try to maximize utility within a given budget. Then production factor supply and the financial needs. Or profit maximization occur inside the enterprise under given technology. Then supply the good, production factor demand comes. This is a structure. Okay, next section. So, I explained the structure, the economics, the focusing on the three component, market, household budget, and enterprises. We discussed, okay, prices determined such as the demand equivalent to the supply. Okay, maximize utility within a given budget in household budget, and profit maximization in auger and the given technology in the enterprise sizes. Now we try to define mathematically one by one. This is the second section, and we need to represent corporate behavior in mathematical way. First, okay, I say corporate or firm. Assumption, firms act to maximize profit. This is a natural. Okay, some people try to buy at a very low cost, depending on the case, or trust with the customer. But in the computational economy, we try to formulate very simple way. Firms are price taker. Okay, the customer need, oh, please set this price, this from customer. But in this, the formulation, no, provider set prices. Therefore, the price should be high if the product can be sold in the market, or if this, we need they have to change the prices depending on the circumstances. Firstly, function is defined like this. Input is vector of x, x1 and x1. There's some input. Okay, if you make one product, firm needs a lot of the purchase for making. Therefore, parts A, parts B, parts C, something like that. As these here, 1 to n parts is necessary for making one product. Amount of the input for the defined x1, x2, it means how many pieces are necessary for individual parts, and then product can be obtained by the function f of the vector x. Why the production volume? How many number of the products can be provided from this form is defined this function, and x is the input vector. It can be visualized, okay, different vector input, x1, x2, x3, x4, there's some spaces. Then you need to take for the y for the amount of the production. So therefore, in this assumption, this implies firm provide y input to the n xi, and n equal 1 to n. This is the mathematical formulation. Please note y is not vector here, and this is a single variable in this formulation. Then again, from economic, the conceptual, the basement of the concept of the economy, and they also provided an additional assumption. Production technology constantly has the property of the constant return to scale. What is the scale? Scale in this cases, more technically we say linear homogeneity, but you can understand just simply linearity. Linearity means if some value the multiply the input, you can take amount of the product in the same the multiplication. This is the formulation of the linearity. it says A, blah, blah, blah. Then it comes out A multiply function X. This is also the assumption. So this says, yes, if, okay, you need to one product, okay, 1, 2, 3, 4 pieces necessary in input. Okay, I know the 2-piece product, you need to multiply how many pieces, this. Then you can get. This might be the natural in production. If there's no some specific limitation to production in firms, because naturally we need to think about it, depending on the size of the facility in the factory. Even if you can multiply 100 products can be obtained or not. It's a bit considerable on the dependent case. But on this formulation, we need to think about the linearity here. This is the basement of the definition. Second point, the considering of the corporate behavior, profit of the firm, how we can calculate this profit of the corporate behavior. Yes, this is also very simple. Yes, income. Income means the set of the prices of the product. You can get income by multiplication the P by the Y. How many pieces and how much? Then if it's 100 yen, okay, then the 10 pieces, okay, 10,000 yen you can get. But you also paid for the input cost to make this product. That's why you need to substitute the old cost of the input. You may think about the cost of the worker inside, blah, blah, blah. But now, very simple formulation, profit can be obtained income minus input cost. This is the formulation. Then, in the sense of the formulation F, what kind of F we can determine is also the strong the assumption according to the next following section. You can understand very more precisely. But now we set that the mathematical formulation F should be quasi-concave function. Later, you need to calculate the CGE. What kind of function how the function, the balance, the value is balances. In this sense, function should have some specific profit property. Then you may remember that the lecture in the fundamental mathematical B, we discussed about the relationship. Yes, this is a parameter lambda. You can change the parameter like from x1 to x2 and changing the point. Then you can get the result. Okay, here. On the function, if it's under in this line defined from the function, this is the convex. And reversely, you can think about concave function is this way. Okay, then you can think about the same way in comparison of this value and this. Okay, and quasi-concave or quasi-convex means more precisely we are discussing concave convex is this definition, but instead of that you can use max of this function. Okay, which is the max? Which is max? In this sense, it's not fitted all the way. Just you can set the maximum point of this and this, then under this, okay, that's enough. On this, the formulation. Okay. This is the second point. Okay, the next section, 2.1, profit maximization action. It represents what kind of behavior the firms take. This is the formulated again. The first assumption again, firms are price taker to maximize profit. Profit is defined as this way. Therefore, mathematically, we can focus phi as a profit based on the PY, price of the profit, and input prices. More precise mathematical way, you can describe max and the condition of the x vector phi equal PYFX and minus this factor. If PY and P vector P is given. There is no specific condition as a subject to here, just providing. Therefore, it means this is the constraint here under here. Therefore, it is an unconstrained optimization problem. After the formulation, you need to select some of the better solver in the computer program or framework architecture. You need to solve this optimization problem after the formulation. Equation 3 represent here. Then we assume quasi-concave function. If corporate at the firm try to provide, it's saturated, there's some peak. We need to find some peak here. This is kind of balancing point. Then, if we assume this is a kind of the continuous and differential function with n vector, you need to think about surface like this. And then, oh, what is the maximum point like this? Oh, this is here. Then you can find this by using differential integral. We introduce partial differentials here according to the function phi here. Then calculate it. The component is f and this multiplication. Therefore, you can simply apply partial differential for this component. If you focus on specific dimension I, this partial differentials for this, you can simply obtain PI only. Okay, other x, if you focus on the x1, x2, x3, x4, the constant, that's why you only get the P1 only. So similarly, then this is the function, then it's the partial differentials, and this is the constant, then you can obtain. What it represents is in this the structured economy, yes, marginal product value here mean this input, okay? You can control input to maximize profit. Therefore, the input is controlled so that marginal price of the input is equivalent to the input prices. This is the actual meaning. That's why you can formulate this, then calculate this. Focusing on the only one dimension, this is the segmentation of the aspects of the X1 have some kind of the structure. Then it has a peak point. If it's continuous function, then get this as marginal the point. Okay. Okay. Final topic in the morning in the next section, and discuss about of the condition or profit maximization and last word. So it's safe. Now you gradually understand the structure of the functional economy. If appropriate assumption, this, and then consideration of the profile of the function, yes, we can get some point to maximum profit. In these cases, we are focusing on the corporate behavior. This is the aspect only inside the here, okay? This is the kind of the vision, how enterprise see the market. Then market will change depending on the market, their own behavior and this formulation. We also provided the assumption, this function, profit, and structure the profit, the profit function as a continuous differential function. Then we can introduce partial differential to take this point. And even if there's a multiple input having like this, try to maximize it. Therefore, we can formulate it is in the unconstrained optimization problem. According to summary and corporate behavior, this section, yes, it says once input vector X is determined according to the equation 1, product amount here is defined as F. F is changing depending on the input. So then input have to set according to this maximization. Therefore, you can describe why input PY the P, but actually it's this was F inside here X. X is determined by this and this, okay, recursively, because X is determined because the PY and the P, okay, then change, then set this. Therefore, maximize profit is determine the profit, this function in this formulation after definition X in this behavior. Okay, this is kind of the formulation of the corporate behavior in this case, but we need to set formulation. For example, F should be the differential and the continuous function. And additionally, this paper, the paper said first order condition is satisfied here, but more precisely, second order condition exists to get final result. This is a bit analytical difficult. The refer to the Simmons and the Brame, 1994, but people practically use CES function. Later we discuss, and then CES function satisfy second order function. That's why once you use CES function, no problem at all. You can compute this behavior. This is the first one, the corporate behavior. Yes.
My question is about our problem here in the non-linear.
Yes.
My question is
Yes.
about the non-linearity.
Yes.
Is this the non-linearity problem?
Exactly.
Okay.
Because of the if function f is line, this is a linear optimization. Okay. Nonlinear optimization is a bit difficult. It's compute. Always we have to find this point. Some approximation function. Linear the programming to solve linear optimization problem. Kind of the finding segmentation is line. Okay, how the function can be maximized in the range of the rectangle, then get this point. But the nonlinear the problem here, like this curvature and then peak point. It's not so easy to take like the linear programming. That's why some specific computational framework is necessary to solve this way. That's why the people try to compete the actual implementation of the for the making solver for the nonlinear the optimization problem. Is it okay?
Yeah. Thank you.
Thank you very much.